My name is Khushi Murthy. I'm currently in third year engineering pursuing artificial intelligence and data science from NITI Meenakshi Institute of Technology. So under the Samsung Innovation Campus, I've built a capstone project. So I had the topic medical X-ray interpreter and my model is MedVision AI. So looking into the problem statement, medical X-ray images are very complex. They have very complex visual information which are difficult to understand by normal people. Like you just take an X-ray and it's difficult to understand whether you have some disease, is there something, or which disease do you have. So I've tried to find a solution to that. Yes, there are expert radiologists, but we can just visualize what is there in the X-ray. So MedVision AI is an AI-powered medical image analyzer. It is an end-to-end artificial intelligence and machine learning model. So looking into my project, the objectives are analyzing the X-ray. I have done image pre-processing and I have included CNN-based classification. This is the system architecture that when a user uses the model, he'll get a front end. We can put an X-ray image which will be processed in the backend. Then the classifier predicts if there are any abnormalities in the X-ray image or is it okay. Then we use NLP to generate a report. So it's an AI generated report and the report will have final result, the accuracy, to what percentage the disease is there and the prediction. And this is the end-to-end workflow. Looking into the X-ray image, only the PNG, JPEG and JPG files are supported. Looking at input validation. So there has to be a file existing and it checks file format, image readability and everything. Next, going to the CNN-based classification. As I said, I've used CNN classifier, that is convolutional neural networks, in my project. Next, I'll yes, the tech stack. The programming is entirely done in Python. I've used TensorFlow, that's Keras, and for data pre-processing, I've used NumPy, Pandas. And looking into the front end, I've used completely HTML, CSS, and JavaScript. The development was entirely done on VS Code. And coming to the data set. So I took data set from the National Institute of Health. It has chest X-rays data set. The data set was around 40 GB that had 1,12,000 X-ray images, out of which many images did not even have any diseases and half of them had almost infiltration images. That's 14 diseases with around 1,12,000 images. So there has to be done pre-processing, which I have done and I'll show you in the next. Next comes the model training. As I said, first the data set was taken, it was cleaned, that removing any missing data and all. Then the pre-processing was performed. After that, I've trained the model. And then data augmentation, because let's take example hernia. In my data set, hernia had only 200 images, whereas infiltration had around 22,000 images, which made the data set imbalanced. So first thing I did was data augmentation. What data augmentation does is, by data augmentation, we can slightly rotate the images or zoom the images that will create variants of the current chest X-ray that will become easy in training the model. And the second thing I did was assigning weights. Like as hernia had less number of images, I assigned more weight to hernia and less weight to the infiltration, which I'll show next. Then model evaluation. The classification metrics, accuracy, precision will call. So next, looking into the EDA, that is exploratory data analysis. I have trained my model on Kaggle because the data set was very huge, which was 40 GB. So it was present, the same entire data set was present on the Kaggle. So my model is trained on the Kaggle. As we can see here, these are the 14 classes or the 14 diseases that the data set had. And most of the X-ray images, like 60,000 images, had no findings at all. This is the chart that shows there were no findings. And images per patient in the data, like 25,000 patients were not having any disease at all. And then I've also analyzed the gender distribution, like how many male patients chest x-rays are there and how many female patient chest x-rays are there. So this is all the data analysis to understand better about the data set given. And this is the heat map related to that. Next, yes, and this is the data pre-processing. As I said, all the diseases, 14 diseases I've taken, and I've divided the data set. That is training images 89,000, validation images is 11,000, and testing images is 10,000. So I made sure that there is no data leakage into the testing model. These are the number of images I said for diseases. That is, we can say infiltration has 19,800 images, while hernia has only 200 images, which can be seen through this chart. So for that reason, this is the processing. Yes, so for that I've done data augmentation, as you can see here. When the X-rays are slightly rotated or zoomed. And this is the total parameters in my model. Yes, this is the positive class weights that are assigned to the model, and class weights are assigned by seeing the number of chest X-ray images. As I said, infiltration images were more, so the assigned weight is less, while hernia, the images were very less, so the assigned weight is more. This was the pre-processing part. And as you can see, I did not train the model completely at once. It was done in batches. So this is the training batch, validation batch, and the testing batch. After that, at last I did fine tuning of the model. This is the evaluation metrics. The test AUC was 76, that is 0.76, and precision was 0.53. And this is the area ROC curve for all the 14 diseases, where we can see that cardiomyopathy has around 0.82 and consolidation has 0.79. That is, it's different for every disease. And this is the classification report of all the 14 diseases, and the AUC, that's the area under curve. As we can see, every disease has a decent AUC. And looking, as I said, that when we put an X-ray image, the model processes it and then analyzes if there are any diseases. So to analyze it, there is a particular threshold or the percentage for every disease. So these are the threshold for every disease. If it is detected more than that, only then the disease will be taken as positive. And this is the app.py, that is the entire backend of the code of my model. And I have also put disease knowledge so that everyone, the model knows what is the problem, or for every disease what should be done. And I have also integrated Gemini report. This is the Gemini report part. And the PDF.generator will create the report PDF. Predictor, this part will predict which disease is it. this is the pre-processing code. I have also tested each and everything separately so that there won't be any issue with coming to the model. This is my model MedVision AI. Let's check it out. So I'll upload a image that is test image. So this is a normal chest X-ray. Let's see, which is like prone to some diseases, but it doesn't have any disease. Let's see what it detects. So it is showing no confident finding detected, while it is prone to infiltration sometimes. So let's change the image. Analyze. So now it's 81% model score. It's showing that the disease is effusion, but now we don't know what is effusion. So we can ask here what is effusion. The AI chat says that pleural effusion refers to abnormal collection of fluid around the lungs. So that's effusion. This is how like we'll get to know. But as we know, AI is not doctor. So it also recommends that discuss the finding with a qualified healthcare professional. And we can also download report from here. And this is how the report looks. As you can see, probability effusion is 81%. And the secondary findings, that is the next highest, is the other diseases, which are 22 and 12%. The recommendation, as it is AI, we cannot let people take decisions by their own. AI can only predict the disease, but any major decision should be taken by a experienced radiotherapist or radiologist. So recommendation is consult to a certified radiologist. And so this is my project.